Welcome to the post-launch press conference for NASA's Lunar Atmosphere and Dust Environment Explorer, or LADEE. I'm Keith Kohler, News Chief here at NASA Wallops Flight Facility on the Eastern Shore of Virginia. LADEE was launched tonight at 11:27 p.m., September 6th, on a U.S. Air Force Minotaur 5 rocket from the Mid-Atlantic Regional Spaceport's Pad 0B. I would like to introduce tonight's panel members: Colonel Gillespie, U.S. Air Force Space and Missile Systems Center; John Grunsfeld, Associate Administrator for the Science Mission Directorate at NASA Headquarters in Washington, D.C.; Pete Warden, Center Director, Ames Research Center, Moffett Field, California. We'll have each of our panel members say a few words, and then we'll take questions here in the auditorium, also from those that may be calling in. So, Colonel, if you'd like to begin.
Yeah, absolutely. If I can I have the launch picture or launch photo, please? They say, you know, a picture's worth 1,000 words. This may be worth an order of magnitude more than that. It was a picture-perfect launch. It was very, very, very close to exactly how we had scripted it, and it was just an amazing event. As I said earlier in the evening, you know, we were clean and green going into the launch window, and it stayed that way. The weather cooperated beyond belief, but the team itself, the range, the Ames Research Center team, the Wallops Flight Facility, and everybody that was involved just absolutely performed remarkable all the way up to T0. And then after that, the rocket itself did everything that we asked of it, and it was, again, a picture-perfect mission.
John.
Well, first of all, I'd like to say thank you to the United States Air Force for getting us on our way to the moon. It was just a beautiful evening, a beautiful Eastern Shore evening, and I think Wallops really cooked up the best possible situation for helping us to unravel the mysteries of the lunar atmosphere with LADEE. And so, you know, I know I'm always incredibly nervous, you know, especially during the launch phases, because there's so many things that can go wrong. You know, it looked smooth, it looked easy, and I just want to remind everyone that, you know, just building a spacecraft is not easy. Getting it to the launch pad, you know, takes an enormous amount of effort from a lot of people, and launching a rocket is hard. And there's so many things that we control that tonight just went spectacularly well. There's things that we don't control, you know, boats in the range and, you know, all kinds of things. But, you know, tonight, you know, Celine was looking kindly on us, and we were able to get off right on time, and it really was very beautiful. You know, the next big event that always worries me is fairing separation, and the fairing separated right on schedule, and the Minotaur continued taking us towards the lunar trajectory. And the next new thing was the fifth stage, and the fifth stage fired off right on time, and spacecraft separation is the final big event, and the spacecraft separated, and we communicated with the satellite as it powered up and reported back that it was doing well. However, like any new venture, things don't always go quite as planned. As the spacecraft started powering systems up, the computer evaluates the rates, determined that the thrusters weren't required, powered up the reaction wheels, and then powered off the reaction wheels. And so we're evaluating, the spacecraft's doing fine. We're evaluating what's going on, you know, what the signature was. You know, fortunately, this spacecraft was designed with a lot of smarts. It did the right thing. It saw something it didn't like, and it reported back to the team, and the team's evaluating what the next steps are. Actually, why don't I hand it over to Pete? You know, he's going to tell you a little bit about the inherent design of the spacecraft that protects it for things like this.
Well, as the spacecraft comes off the fifth stage, there is residual rates where it's moving in X, Y, and Z directions, and we had two modes on it. And one mode was that if it was spinning too fast or above a certain level, we would fire the thrusters. We prefer not to do that because it uses up fuel. The other mode was where we would turn on the reaction wheels, and they would orient the spacecraft and take out these excess rates. When we did that, the as John said, the computer said, a little too much current being drawn here, and it turned them off, turned them in a safe mode. We are now taking the data and looking at it. This is not an unusual event in spacecraft. The neat thing about this spacecraft is you can see what looks a lot different than most spacecraft. It doesn't have panels sticking out. And I might add that was an argument early on whether we were going to have panels for the power. So we did it this way. What this gives us a really added strength is that we don't have to do anything very quickly. We've got 20 days before we get to the moon, and so we can sit back and figure out how to iron out these problems and how best to get us into a finally stable attitude so we can get into lunar orbit. So the team is now looking through the data. They're collecting a lot more data. We've got perfect connectivity. All the systems on the spacecraft are working as planned. So we hope in the next few days to get these bugs ironed out and get the science that we expect.
Okay, thank you, Pete. Okay, we'll now take questions from the auditorium. If you could raise your hand, we'll get a mic to you, and then state your name, affiliation, and whom you would like to answer the question. So, Stephen?
Thanks. Question for General Worden. Just to make sure I understood you correctly, the spacecraft, is it using thrusters currently for attitude control? Are you in communication with the spacecraft? And also, do you happen to know the manufacturer of the reaction wheels?
On the first one, no, we haven't fired the thrusters. We're not using the thrusters. We don't need to. We are in full communication with the spacecraft, and I don't know the name of the manufacturer of the reaction wheels. And there's no indication there's any problem with reaction wheels. They came on as anticipated. It was just that some of them were drawing more power than there was a limit we had set, which indicated they were probably running a little faster than we would like. So the computer says, hey, turn them off until we can figure out what the details are. And again, everything worked as it was supposed to. But it's in basically a safe state right now, so that we can take our time to figure out how to get these things ironed out, and we're confident we will do so.
Next question. Ken?
Hi, Ken Kramer for Universe Today. Pete, can you just clarify? I'm not quite clear on the health of the spacecraft. You expect this mission still to be fully successful?
Everything we know now, it will be. But again, and until you finish the mission, you can't say it's fully successful. We do have some things we've got to iron out, and that's what we're going to do, hopefully fairly quickly. But we're not rushing into doing anything, because we've got the design allows us to take a few days to get things squared away.
How much time do you actually have before you have to take any action?
Probably 15, 20 days.
Okay, and it will just continue in its orbit around the
Well,
Earth.
it's on its way to the moon, and it's on a perfect trajectory. There's nothing that we have to do soon. I mean, we have a number of different ways to get the spacecraft in the right orientation, using the thrusters, using the reaction wheels, and so forth.
Thank you.
Next question. Okay, seeing no questions, we will continue to follow this, and we'll post any status reports as we go along. So that concludes tonight's news conference. You can get more information on LADEE at www.nasa.gov/LADEE. And thank you for attending, and have a good night.
Thanks.
T minus
T-minus
30 seconds and counting. T minus 20 seconds and counting. T minus 15. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff of the Venator 5 with LADEE, pursuing a rift about moon dust and the lunar atmosphere.
Vehicles down passing Mach 4. Stage 2 motor pressure is nominal. Vehicle attitude and flight paths are nominal. Vehicle avionics and power systems are performing as expected. T plus 85 seconds, stage 2 motor pressure remains nominal at a maximum thrust of 320,000 pounds. Vehicle attitude and flight paths are nominal. Altitude is 60 kilometers. Approaching stage 2 burnout at 115 seconds, followed by a 20-second coast phase and a stage 2 separation and stage 3 ignition event. Stage 2 burnout. Stage 2 separation, stage 3 ignition. Stage 3 motor pressure is nominal. Vehicle attitude and flight path are nominal. Fairing separation is confirmed. T plus 3 minutes. Stage 3 motor pressure remains nominal at a maximum thrust of 70,000 pounds.
We're 3 minutes 17 seconds into the flight of the Venator 5 with LADEE. We have a map that shows where the rocket is as it flies downrange off the coast of
Stage 3 burnout, guidance
Virginia.
solution confirmed or converged. Stage 4 ignition will occur at T plus 440 seconds.
We have ground contact now from the Bermuda tracking station. Bermuda will track until we acquire through the tracking and data relay satellite system.
Vehicle avionics and power systems are nominal. T plus 4 minutes. Vehicle avionics and power systems are nominal. Minotaur 5 is 900 kilometers downrange at an altitude of 205 kilometers, traveling at a speed of 6 kilometers per second.
Flight termination system is disabled as planned.
Wallops is still tracking,
Vehicle attitude is nominal.
and Bermuda has acquired. Turning off the flight termination system means the launch vehicle is on track, on course.
Sorry. Stage 4